Part 2 here. The arithmetic mean or average of two numbers, x and y, is x plus y divided by 2. Again, to find the average of two numbers, we add them up, divide by however many there are. Here, we have two numbers, so we divide by 2. In an arithmetic sequence, the middle term of any three consecutive terms is the arithmetic mean of the other two terms. So in example 3, we're going to find the missing term of the sequence here. We have 15, and then some number we don't know, and then 59. So the number in the middle is the average of the two numbers on each side. So we take 15 plus 59 and divide by 2. Again, to find the average, we add them up, divide by how many there are. 15 plus 59 is 74, divided by 2 is 37. Which means our number here is 37. And we can check that by checking our common difference. 15 to 37 is plus 22, and 37 to 59 is plus 22. So our common difference is the same, which means 37 is the number that we're looking for. The 9th and 11th terms of a sequence are 132 and 98. What is the 10th term? So we have 9, 10, 11. 9th term is 132. We don't know this term. And we know 98 is our 11th term. So to find the term in the middle, we find our average. We take our two values and add them up. Divide by 2. 132 plus 98 is going to be 230. Divided by 2. It's 115. We can check our common difference here. 132 to 115 is minus 17, and 115 to 98 is minus 17. So those work, which means 115 is our answer here. That is our 10th term. Example 4 is using explicit formula for arithmetic sequences. The number of seats in the first 13 rows of a section, sorry I got cut off over here a little bit, of the arena form an arithmetic sequence. Rows 1 and 2 are shown in the diagram on page 574. So if you look at page 574, okay, it gives us rows 1 and 2. It says row 1 is 14 seats, and row 2 is 16 seats. We want to know how many seats are in row 13. Okay, our sequence right now is 14, then 16, then we don't know, and eventually we want to know our 13th term. Again, we could use our recursive formula here, but we'd have to keep adding our common difference every time. And we don't really want to have to do more work than necessary. So instead of coming up with a formula for recursive, we're going to use explicit. From 14 to 16 is add 2. And we know that these form an arithmetic sequence, which means this difference, called our common difference, is always going to be the same. Our framework for an explicit, for a sequence and explicit formula is a of n equals our first term plus n minus 1 times our common difference. And the n minus 1 there is because we don't take that common difference to our first term, but we take it to every term after that. So whatever term we're looking for, we've actually added our common difference 1 time less than that. Here, we know some values. We know our first term is 14, and we've determined that our common difference is 2. To find the 13th, we plug 13 in for n. And the amount or value of our 13th term is 14 plus 13 minus 1 times 2 We're just going to simplify here. And we get 38. So how many seats are in row 13? We get 38 seats. And again, we could have extended the pattern, we could have drawn a picture, we could have used any of our most of our problem solving strategies there. We could have made a list, we could have worked, guessed and checked, looked for the pattern, which is kind of what we did here with finding this common difference. And then we came up with an equation, which writing an equation is one of our problem solving strategies that I have up on the board as well. Now, the number of seats in the first 16 rows in a curved section of another arena form an arithmetic sequence. If there are 20 seats in row 1 and 23 seats in row 2, how many seats are in row 16? So, we have row 1, row 2. Row 1 is 20, row 2 is 23. So, our sequence, if we were to list out all of our numbers, would be 20, 23, and then we'd add numbers along the way until eventually we got to row 16. It tells us here that it's an arithmetic sequence, which means we can find our common difference. The change between any two consecutive terms is always the same. So from 20 to 23, we add 3. And if you're not sure where that number came from, guys, we always take our second one minus our first one to get that common difference. And that'll work every time to find the common difference. So sometimes it's pretty easy to see with these smaller numbers, but if our numbers get bigger and we're like not sure where that came from, just subtract. Okay, now we want to find row 16. So again, instead of adding every single time, what we can do is we can come up with that formula. Again, A of n equals first number plus our common difference, n minus 1 times our common difference. That's our framework. That's what we need every time. Now we can plug numbers in. We know our first term is 20, and we know our common difference is 3. So this is our explicit formula. And it's explicit because it's exactly one equation that we use to find the exact value of what we're looking for. We don't have to repeatedly add things like we do in the recursive formula. We're looking for 16, so I'm going to plug 16 in for n. The amount of our 16th term is 20 plus 16 minus 1, that n minus 1, times our common difference. 20 plus 15 times 3, 20 plus 45, gives me 65 seats. And that's the amount of our 16th term. A real quick recap here. In an arithmetic sequence, the difference between any two consecutive terms is always the same number. A sequence can be defined explicitly by describing its nth term with a formula using n, or recursively by stating its first term in a formula for its nth term using the n minus 1 term, so the term before it. Here are our formulas. A sub n equals a sub 1 plus n minus 1 times our common difference. That's our explicit. Again, it's exactly one formula. And we can find any exact value. So if we want the 100th term, the 400th term, the 12th term, we can plug 12 in, 100 in, 400 in, whatever our value is, whatever term for n, and solve. This is our recursive formula. Okay, in both of them we had to say where we started. We say it inside our formula for explicit. For recursive, we just have to list it. Because in recursive, we repeatedly add a value, our common difference here. So we need to know where to start from. Okay, so two different equations here in recursive. And in recursive, we take a term. To get a term, we take the term before it and add our common difference. Then we take that term, add a common difference. The term before, add our common difference to get the term we're looking for. And these both can give us the same sequence, just different ways. And there are your problems.